Good morning. Thanks for coming to the session. And I'd like to do a quick survey. How many people attended the SQL Azure session yesterday, just so I have an idea? All right, a lot of people. Well, good. So maybe I can be less verbose about some of the overview stuff and cover a little more of the interesting stuff. My name is Tony Petrosian. I'm a program manager with the SQL Azure team in the development organization, mainly responsible for the backend database technologies, replication, failover. And been working on SQL Azure for a couple of years now and working on databases for a couple of decades now. So I always get a little excited about talking about databases. So let's get started. So I'll do a quick recap of the service, and then we'll cover some of the patterns and practices for the various components that you have to deal with in a SQL Azure system. The server management, some security stuff, connectivity, tracing, and dealing with large amounts of data, getting them in and out of the cloud. So we'll do some quick demos and a little bit of coding, and then I'll leave some time at the end so we can have a good question and answer session. Yesterday's session, we were trying to pack a lot of stuff, so we didn't leave much time for questions. So, all right, so SQL Azure, database as a service. You can create servers and databases on demand. There's a portal that you use for managing the servers. And the server is the only thing that you really have to manage through the portal. And then the databases are managed through T-SQL, as always, for just like any other SQL server. So that's kind of the two administration points that you have to deal with. Over time, we're going to provide APIs so you don't have to go to the portal. You can programmatically deal with creating servers. But for now, creating servers is associated with subscription and so on. So that'll be a little later. Then authentication and logins and all of that is managed through T-SQL, through whatever tools that you're used to using. So what does this SQL Azure really look like? So there are several layers to the system, and I'm going to spend some time describing the various layers. So I think with the patterns and practices session, the more you know about what's behind the scene, the better you can leverage the system to work for you. So our goal is to give you as much information as possible about the behind the scenes, as well as just how to use it. So behind the scene, we have a large cluster, and most of the systems within the cluster are running the database. This is a special version of SQL Server 2008 with some additions that we've put into it for high availability and replication and a few other things. It's very tightly integrated with the environment for managing the large cluster. Everything is automated so that there's no manual intervention. Upgrades are all done online. We have a rolling upgrade mechanism. So all of that lives on that red layer at the bottom. And you can see that we have the scalability and availability fabric. The fabric is basically responsible for keeping track of all the application pieces that are running and their health. So above and beyond keeping track of machines, what machine is up, what machine is down, we also keep track of the entire stack. So when a node disappears, for whatever reason, if the hardware blows up, the disks die, or some process fails, or some piece of code had a bug and it died, the fabric is the one responsible for detecting that. And as soon as the fabric detects failures, it initiates a failover mechanism to basically eliminate the dead node and recover whatever needs to be recovered and switch the primary databases. So you see very little time in disruption of your service, we can recover and do a failover in a matter of seconds when a node actually dies. And we use this technology for our upgrades as well, because at any point we can go and turn off a bunch of machines and nobody will notice, because the cluster has a lot more capacity in order to sustain failures and upgrades and so on. So go turn things off, quick failovers happen, and nobody notices. And this is how we do the upgrades and so on. So the fabric is also responsible for load balancing and detecting the load on the entire cluster as well as any individual node. So, and we move things around in order to compensate for any peaks in usage. And our goal is to maintain a very even utilization and performance throughout the cluster, not just the nodes. So 2 dimensions to that. Above that, you see the blue layer, which is the gateway system. This is the set of systems that are actually sitting in front of the service and are facing the internet. So when you make a connection to your database, you don't actually connect to one of those red boxes. You just connect to one of the blue boxes. And the gateway is responsible for all of the security mechanisms, the firewalls, and actually checking your credentials. And after all the security passes are done, ensures that it's not a DDoS attack or a DOS attack, or somebody's not trying to repeatedly log into your database, trying different passwords. Once the gateway is sure that that connection is legit, it will actually figure out where it needs to connect in the back end on one of the red boxes. And that's when your TDS session is established. And that's when you can start doing your T-SQL from your application or whatever client library that you might be using. The connections to the gateways are, of course, load balanced. So we have lots of gateway machines. And once their job is done with establishing the session, they set up a pass-through pipe, basically, from wherever your client is to the back end, and the gateway gets out of the way, and then you get a free channel. Of course, it's all SSL, and it's all enforced. There are a few other things that the gateway enforces, like it won't let you use common admin login names and so on. And then in front of the load balancer is finally the internet, where you actually can come in, or Windows Azure, where there's the connection point. As far as connecting, all the client libraries are the standard client libraries for SQL. So what is this server? The server is the geolocation indicator. When you create a server, you decide where that server is going to be. You can choose Europe, Asia, North America, South Central, North Central, and whatever other locations that over time they're going to be available. And it's also your administration point for logins and firewalls and so on. And it's the billing instrument. We keep track of the server and all the stuff that's in the server. So creating servers is really easy. It's a matter of you go to the portal and you create a server. But how many servers do you need? And there's no physical manifestation of a server. So your databases are not associated with some physical VM or a box or anything physical where the server happens to be. The server is just a logical concept of grouping of databases. So there's really no reason to create multiple servers for performance unless you want these servers to be in different geographies. So if you want to have a server in Europe and a server in Asia and a server in South Central US, because your application runs there, then it's a good idea to create a server in those locations. But creating 5 servers in the same location doesn't really do anything for performance. Now, you would do that if you need 5 different billing instruments. Like, you really want to have 5 different bills showing 5 different set of servers. So that's another reason to create more servers. But in general, fewer servers you have, easier time you'll have administering logins and firewalls and such, because all of that is concentrated in a server. So again, other than billing and geolocation, you should not need to create servers. Then you go create databases within the server as you like. As I mentioned earlier, the portal is where you administer the server. You can add servers and drop servers. When you add and drop servers, the add of a server is fairly synchronous, but the drop of a server might take some time. It just you submit it and you move on. You don't have to wait there and watch it drop. And once you get a server, you get a master database. This looks like the SQL Server master database. Master database happens to be another database, just like a user database that you would create. There's really no difference, other than it's read-only, and you can't insert or create tables in there. But you can execute stored procedures to manage your firewall records and so on. And so the whole notion of this master database, which is, again, just another database, highly replicated and available, is for you to have a place to keep track of all your databases and look at the metadata and look at your billing information. So a quick note about the network access control. As I mentioned, every server gets a firewall, and you're in full control of the firewall. And this is basically an IP filtering mechanism that the gateway is responsible for. You can give it a range of IP addresses or a single IP address, and you can use a range of 0 to 255, 255, 255, 255, and open up to the world. Probably not a good idea. The smaller the range, the better off you are. In some cases where you can't really figure out, let's say you have an ISP, and the ISP gives you a dynamic IP address, DHCP, through DHCP, and you really don't know every day it changes. Well, you can still find the range, maybe at the A-class level, to limit the range which you allow, so that people from various countries in the world where usually attackers work through won't have access to your database. So I have lots of rules in mind for various places that I go, and that's usually covers. So you don't have to stick with single IP. But if you do know the exact IP address, then you can stick with the single IP addresses, right? So authentication and authorization. Other than the live ID that you use for the server management, which is creating new servers and administering the server, you get to create an admin login for your databases. And then that first login is basically the DB owners when you create databases. After that, you just create logins normally as you do with SQL Server. Create as many logins as you want. The logins will be in the master, and they'll be available for all of your databases. And then the admin login has privileges for creating and dropping databases. So it's pretty easy to access your logins because they're in the master, and you can actually go query the master, and you'll see. And if you want to know what's in the master, you can just do an exec sp_tables, and you'll see every table and view which exists in the master. And some of it is the pretty standard SQL Server stuff that you've seen before, and some of them are new stuff that we've done for SQL Azure. And we'll take a look at a couple of those. So for billing and reporting, if you connect to your master database and actually go look at sys.bandwidth usage, you will see your bandwidth usage. Bandwidth happens to be the only thing which we charge you in addition to the monthly fee for your database, which is really not a monthly fee, it's a daily fee. But the bandwidth information is kept there. And of course, this database usage is also where we keep track of how many databases you had at any given day. And a day starts at 00 UTC and ends at 2400 UTC. So we happen to be in Pacific time zone. Some data centers are scattered all throughout the globe. Customers are everywhere. So we couldn't settle on any kind of a time zone to use, so we settled on UTC. So you always know when the day starts and the day ends, regardless of your time zone. So any day, we take a look at how many databases you had, and that's the number of databases you get charged for that day. So if you have a 1 gig database, that'll be 34 cents. And adds up to $10 a month for the 1 gig database. So if you create 50 databases and use them for a few hours and drop them, that'll be 50 times 34 cents. Right? So that's kind of the flat per database fee. So connecting to SQL Azure, it should look very familiar because it's very much like SQL Server. The connection string is pretty much normal connect string. You can use any of the current library calls to build connection strings for SQL Azure. There's a couple of oddities in there. There are some versions of the client libraries that are quite old, and they don't pass the proper server names and database names and such. So in some cases where you see user at server, that's our way of passing the proper names so that we can get the older versions of the client libraries to work. So if you find a version of OSQL from several years ago, it'll still work. You just have to do that. So it's just better practice to always use the user at server, and that kind of makes it a lot easier. You can also go through the portal and pick any database, and there's a button which you push, and it'll show the connect string for that particular database. And I always go through the portal because I forget the server names. Now, server names are random, and there's quite a lot of debate about that, and eventually we settled on the randomness because it eliminates the need to manage trademark information and vanity names and so on. And bogarting of names, and then disputes and lawsuits. So random strings kind of solved all that problem. So when you connect to SQL Azure, you specify a database. At that point, you're connected to that database. That's a little subtle difference from SQL Server, where when you connect to SQL Server, you connect to the server or the instance. It's a box, it's a physical computer somewhere, and it's got a server running, and the server has a number of databases. And you can change context between one database or another database with just simply saying, use this database, use that database, and use the other database. Because you're connected to a single box and a single instance, that works. However, if you have two boxes, they're running two servers, and each one has 5 or 6 databases on it. Obviously, you can't connect to one and then say use a database from somewhere else. So remembering that SQL Azure is about a cluster of thousands of machines running servers, your databases are all over the place. In fact, you should be happy that your databases are all over the place, because when you create 10 databases, we put them on 10 different machines so that your databases don't contend with each other for resource. So when you want to have a scale out and you want to hammer all your databases, it would be pretty non-productive if they were all on the same machine. So we go out of our way to spread your databases as wide as possible so you can maximize resource utilization. So for those reasons, your databases aren't on one machine, and you can't do the use between. Now, in the future, we'll probably figure out a way to solve that. But for now, you connect to a database. When you want to connect to another database, you have to disconnect or reconnect to the new database, or you have to have another session. When you connect to the master, you see all the master information, all the metadata. And you also can't switch from the master to another database through use. So again, you have to intentionally connect to master or any other database to use it. Now, connection management. So it's probably safe to say that no matter where you're running your databases today or your computers, the chances are that at some point, machines fail, operating systems are rebooted, network devices fail, switches are upgraded, routers are upgraded, somebody steps on a cable. For whatever reason, you get disconnected. Anyone says they've never, ever gotten disconnected from their database, they should feel really lucky. But most of the time, people do face these things. So all it comes down to is frequency of these events and the length of time where you are disconnected. So if somebody reboots an operating system and your database goes away, maybe it'll be back in 5, 10 minutes. Well, you don't want them to do that very often. If somebody's upgrading, maybe the outage is longer. If somebody steps on a cable and nobody notices, maybe it'll take a couple of hours to debug it. Now, in general, if you write applications that have resiliency against these kinds of failure, you'll be happier because your application can deal with these types of failure. Now, the particular situation with Azure is that the length of these failures are extremely small, relatively speaking. So if something happens to a machine and it goes away, we do the failover in a matter of seconds. So you don't have to wait half an hour or 2 hours for that database to come back. Now, because you're reaching this database across the internet, the frequency of these blinks might be higher than what you're used to in the enterprise. So this is the trade-offs. Quick failover. If you're upgrading and for whatever reason your connection goes away, you reconnect 5 seconds later and everything is normal. But it's possible that you get disconnected. So you have to write applications that deal with this. Now, this is a good pattern for anyone doing anything. But if you assume that because of the internet you might get disconnected more frequently, or because of the distance, or because of lack of control over the end-to-end system, right? You might have to deal with disconnects. You might as well write applications that can deal with the disconnects. Again, our promise is that the disconnects, or the length of time when things are unavailable, is extremely short, but they might happen more often. In the enterprise, you have a super-duper billion-dollar system that only goes away once every 5 years, and it only goes away for 10 minutes. You may not bother building resiliency in your application. But I think this is a slightly different scenario. So what causes things to go away? Well, network blips. Now, one of the things we do, if you have an idle session that's been sitting around just doing nothing, we disconnect idle sessions after 5 minutes. Feedback on this is that's pretty annoying. You disconnect me every 5 minutes on my idle sessions. I'm sitting there in SSMS, and I go get a cup of coffee, I come back, and I'm disconnected. We only disconnect if the session is truly idle. So if you had something running, we don't disconnect. Now we're working on improving this to basically have different disconnect behavior in the future. But for now, it's 5 minutes of idle times will get you disconnected, and you have to reconnect. Long-running transactions. Most people are familiar when their DBA knocks out and kills their process because they had a long-running transaction that was keeping the log open for a long period of time. We have long-running transactions, and we kill them as well. Again, the timer on it is 5 minutes. So if you have transactions that the begin transaction, insert, go get a cup of coffee, come back, commit, and that takes longer than 5 minutes, we will kill that transaction. Again, we're trying to improve this and start to distinguish between transactions that are actually doing writes and reads and have different class and categories of it. So I think this experience will be significantly improved in the near future. But for now, 5 minutes is the limit of your transactions. And there's also throttling. If you peg a machine and consume 100% of the CPU or generate excessive IOs for the particular size of database that you have, we will throttle you. And you get very specific errors, and the errors are very clear. why you got throttled. We've done some work in the error messages. So excessive usage in a shared system, you're impacting other people in the system. So if you are gentler to your neighbors and peers, you'll have a better experience. Failover activity. If a machine blows up, which happens, you use commodity machines fail, the entire system is built to deal with failure, right? We anticipate that every day some machine will fail. There's a failover action. Your databases are replicated, transactionally consistent, so you don't lose any data, but you do get disconnected and you have to reconnect. If you're in the middle of a transaction, the transaction will be rolled back. Now, semantically speaking, we follow the rules strictly. This is a transactional database. Just because it's cloud doesn't mean we take liberties with relaxing the rules and semantics of transactions. So transactionally speaking, this thing behaves just like SQL Server. We also have a DOS mitigation. If somebody comes in and is trying to log into your database and they're doing a dictionary attack, we will notice that pretty quickly, and we will blacklist that IP. We put it on a disallow list. So if you come in yourself and you're making a lot of mistakes, or you have the wrong password in your application or whatever, and you keep hammering, we will disallow that IP address. After a few minutes, we allow it back. But this is, again, to ensure that people aren't trying to guess a password, guess a username, guess a database name, guess a server name. At all levels, when you try to do guesses, we knock you out. So some recommendations. The recommendations are that you should follow the SQL Server best practices. Some of the issues are maybe a little more highlighted in the cloud, but definitely there's not much of a departure from the best practices of SQL Server. So connection pooling, use connection pooling. It will make life a lot easier because you can connect, do your statements, queries, transactions, and put the connection back in the pool and manage it that way so you don't get impacted by idle connections and so on. Query parameterization, and we'll go over that, batching. And all of those things are generally good things for SQL Server, and we recommend that you follow it. So what about connection pooling? It's one of those things. So people are usually of the mind that connections are expensive. And you start the application, you make a connection, and you keep that connection for the rest of the life of that application. So if the web server is up for 150 days, you have that one connection, and you hang on to it. That's a bad idea. Connections with connection pooling are not that expensive. You take a connection out of the pool, use it, and put it back. Don't have statements to the database, and in between the statements have user input actions that causes this thing to have unpredictable idle times, right? Now, these things are just good practices in general. Take a connection, use it, put it back in the pool. You need it again, you take it again. And since we're running the servers and we're not charging you for the CPU, don't worry about trying to be efficient. We prefer that you do the work of establishing connections if necessary, rather than having us kill idle connections. So that's the pattern which is recommended by SQL with the using statements. When you're done, everything gets cleaned up, no leaks of connections and so on. So that's a good practice to follow. Connection. So when you get disconnected, just reconnect. That's the best recommendation. The gateway will retry on your behalf. So if, for whatever reason, the backend database was having difficulty, or there was a failover action or whatever, and you get disconnected and you reconnect, the gateway will try to establish the connection for 30 seconds before it gives up. If it does give up, then you can just wait 10 seconds and try again. And you should just retry until you get connected. That's the pattern. If you're getting disconnected because you're running a query that pegs the machine and we're throttling you, then doing it over and over is not going to help. So it's important to catch those error messages and figure out why you got disconnected and take proper actions. Everything that we do leads to a disconnect so that you have one consistent model to program to. So when significant things happen, we disconnect, and you have to basically deal with the disconnect. So this is another pattern where people have a while loop, and then they get a connection, and they go in the connection and do their job and get out and go back in. If you swap that and put the connection outside the while loop, that's bad, right? Because now you have these connections that have undeterministic open times. So avoid that. You can get some trace information. You don't have to do this, but if you're having difficulty and you want to call our service desk, which you can, they would appreciate having this context info, which allows them to do debugging, because everything is traced and everything is logged when errors happen. So it'll be helpful to have that. And the particular pattern for that is you grab the session context, and then that could be used when you call the service desk. This stuff is all in the documentation, so you'll be able to get that, that pattern. Maximizing your performance. Of course, batching, push the logic to the server, use stored procedure, limit the number of round trips. There's absolutely nothing new here, but since your distance from the server is a little larger, the latencies are a little higher, obviously you want to minimize the back and forth, right? So pretty much normal stuff. And parameterizing queries and declare parameters and types and length helps us reduce the cache footprints of your statements. This is even more important for your on-prem stuff because you're paying for the servers and the memory and everything else. So you should be using this because it just basically reduces the footprint. So what does that look like? If you have something like that, the parameter type and size, it has to guess. The optimizer will guess, and that plan will get cached. When you run another one with a different size parameter that looks different than the previous one, that plan will get cached. Now, practically, those queries are exactly the same. It's just the size of the parameters that's different, but they show up as multiple things in a proc cache, and that's not a good thing. So if you declare the length, then you'll have one query plan in the cache. And that shrinks the footprint of the memory. You'll be nicer on the server, nicer to your neighbors. It's a better pattern to follow. So it says scale-out pattern. Databases are literally dime a dozen. So if you can use more databases, you will have a much bigger set of resources working on your behalf. And load balancing becomes a lot easier. So I'll go over that a little bit in more detail. And then, of course, shorter transactions, right? Shorter transactions and stored procedure, again, will improve the performance. And it'll avoid you getting throttled with the long-running transactions, right? So what does this look like? Well, if you're managing lots of data and you manage these data in different databases, this is what happens. The SQL Azure cluster has hundreds, thousands of nodes. And you create this virtual server, the black box. It's literally a virtual grouping of databases. And you create a bunch of databases, and your databases are placed in various nodes. lots of nodes randomly. Well, there's some heuristics there. It's not truly random, but for your purpose, is random. When you can query your master database to figure out what databases are available, and then establish connections to the databases that you need to for executing any particular transaction. Each one of those databases, again, every object in one database, a single database unit, is transactionally consistent. Right? There's no transactional consistency across databases, but we guarantee you that a single database is always consistent. So what happens if a node blinks out? Well, it gets taken out, and a new one takes its place. Again, the new one will be a node that was already there and was hosting your replica for you, and basically the replica comes online in a matter of seconds, and you reconnect. And you really don't know, and you really don't have to know, that the node changed, because the gateway deals with connecting to the right place, wherever that right place happens to be. So that's the pattern where you have to have lots of data. Now, there are some cases where you don't have a lot of data, but you have a lot of transactional needs. There are a lot of queries. And if you saw the keynote stuff in Kelly Blue Book, that was the pattern where they basically have so much query throughput that a single machine cannot handle it. So their data is reasonably static in nature, and they use synchronization to keep the databases in sync. So when they do change the data, the sync framework synchronizes data across all the databases. And in this case, you can put a load balancer in your application, which queries the master, figures out how many databases you have or where the databases are, the names, and then it can access the databases pretty much in whatever fashion, round robin or random, to distribute the load evenly across all the databases. And in this case, again, if there's a failure, the failure happens automatically, and you really don't have to know that that particular database is running on a different machine anymore. And this is a pretty good pattern when you have to scale out a large volume of workload. So talking about migrating applications to SQL Azure, getting data in and out is always an interesting challenge. So we've enabled the bulk copy APIs. So you can always use the bulk copy APIs through ADO.NET. The BCP command works. SSIS also works for getting data in and out. And we support the data synchronization. So if you have to do on-prem, off-prem, synchronization is a good way to go. And there's a session on synchronization on Thursday, last session of the day by Mark. And that's a really good session for figuring out how to get data in and out. So when you're getting data in and out, do it in smaller chunks, do multiple chunks, and add some retry logic as you would normally do, right? So this is an example of the bulk copy APIs that's available in ADO.NET. And again, this is not new, but it's a good pattern to use for getting data in and out. So let's do a quick I'll do a quick demo of SSIS. And I'm going to connect to a machine which is closer to the internet as opposed to the show network which I'm on here. And later I'll compare some data movement between my laptop and the service and my machine, which is sitting on an ISP network. So this is the SQL Server integration services, and I've created a project. And the project basically takes a bunch of flat files and uploads them. And SSIS is part of the standard set of tools that you can get. And this particular one sequences the loads because there are some relationships between the tables that needs to be maintained. So I'm doing an order of load. So I have to wait for certain loads to complete before I start another one. So it's fairly simple to put this thing together. It doesn't require any particular programming. And you just launch it, and you can build this and create binaries, and you just run the binaries. So I'm just running it here in the debugger to show you. But basically, it's a drag and drop sort of an operation to build the package, and then you build the package, and then you can execute the package any way you want. In this case, I loaded a bunch of tables. So the green tables have completed, and the yellow ones are in progress, and the white one hasn't started, because the white one can't start until the first 3 are completed. So it's parallel loading the 3 yellow ones, and once the yellow ones are done, then it'll go after the white one. This is loading millions of rows, so we're not going to wait for it to complete. But no, there's another one completed. So SSIS is a pretty easy tool, no programming involved, drag and drop. I wasn't familiar with it when I did this, and I didn't have to look at the documentation, although I had to wrestle with it a little bit. If I'd looked at the documentation, it probably would have taken maybe 15 minutes, and for me, it was the ordering of the stuff, right? So now, this, on the other hand, I'm familiar with. I did say a couple of decades in databases, right? So command line stuff. So BCP is also a good way to go. I think this is probably the fastest way to get stuff in and out. It's a command line tool that allows you to move data between databases. You can have source destination. In this case, I'm moving data between flat files. So I'm copying the tables, and you can see that the first column there after BCP is the database name, and then followed by the table, and then the location of the source file. And on that first one, the direction is in, and then you give your credentials, and off it goes. So I'm gonna run that here, and just let it run. That would help. So command line, not much to see other than I didn't put my password in there, so. But you have to get it right. So this is pulling data from the service and saving it into the local disk on this particular machine. And you can see it running on this particular machine. And it's running at a pretty good clip. And I can run the same thing here on this machine. And you'll see that it'll run significantly slower because I'm pulling the data out and over the wireless and over the network. So better connections you have, the faster it runs. Well, that's obvious, and that's when you get to do some of the tuning of the batch sizes and your network connections. If you have a slow but wide pipe, then you want to batch and have bigger batches to basically get as much in the pipe as possible. And then it runs at whatever speed that you have between yourself and the internet. So we can go check on the progress of the first guy. And that finished, and it did 8,000 rows per second. And downloaded 200,000 rows while we were chatting. And you can look at the speed running and pulling data back to the laptop significantly slower. I'll just let that run for now. We can come back to it later and see how well it did. So given the fact that you have this network issue and have to move data across the internet, and you have to have a client and a server, and you're keeping resources at both ends, there are other ways to improve. And one way is to use the Windows Azure infrastructure. Well, Windows Azure supports blobs, and they have a very rich set of ways you can get a blob into the service and out of the service. And you can parallelize the blobs and push them in, push them out. And one of the recommendations we have is you could simply take your data and load it as a blob into Windows Azure, and then have a worker role, which you might already have where you're running your application, pick up the blob, and then do the insertion from Windows Azure into SQL Azure. Now, the reason that's good is because parallel uploading a blob is much, much faster, and it's also, you get all the failure recovery and such. Right? So get your data as close to the service as possible, as fast as possible. Now, it just happens that Windows Azure sits next to SQL Azure in the same data center, and all of a sudden, now that distance issue is gone away, and then you can sit there and load your database from the blob. The other direction works pretty well as well, because you can simply take data out of your database and dump it in a blob, and just let it sit there, and then you can pull it out at your leisure. So maybe you want to do your backups at a certain time, or maybe you want to pull your data at a certain point in time, and you do that and dump it in the blob. There's no transfer fees. And maybe you want the blobs pulled out of Windows Azure and bring it home, right? And you could do that at times where it's off-peak, so you're not paying for the bandwidth. Or maybe you want to move these blobs from north-central US to south-central US, so you have a copy of your data in a couple of places, in 2 different data centers, because you want to have your data in more than one place in case a media shower comes and destroys a data center. You'll have it somewhere else. So pushing stuff through the blobs is a pretty good pattern. And I'm going to do a quick demo of that. So let's check on this guy. So this guy's still going. And you can see the difference between my machine on the internet pulling down 200,000 rows and the laptop pulling down 200,000 rows. It's just, it's probably going to take, I would guess, 4 times slower on the laptop. So again, now let's take a look at this demo. We have a little web interface that allows you to create jobs. And I'm connected, and I'm going to pick a data file that I want to go from my laptop to the service. Product.dat. And I need to specify the destination for that. And I'm going to schedule the job. And basically, with the scheduling, what this will do, read the file when the job runs from the laptop, load it up into a blob, schedule it, and once the blob is there and the scheduler runs and says, hey, I have a job to do, there's something to be uploaded, it will basically read the blob from Azure Blob and use the BCP command that we had there in the same way and shove the data into the database. So let's take a look at the code that actually does that. So I'm not going to bother with the web role and all that because that's just a convenience thing. You can just have a web role, that a worker role that does that without any of the web UI. So here's a standard Windows Azure worker role with the usual while true. It opens. And basically, it's looking for jobs. It has a job. It comes down and says, OK, I have a job. The job has a source file. I'm going to go read the source file. And if the job has a format file for BCP, it'll read the format file. And then it'll go to the BCP. So the first thing it does, it reads the blob and dumps it onto the local hard drive of the web role, which is not a persistent storage, but sufficient for that. So let's take a look at what that does. It simply calls Azure helper get Azure blob to stream. Let's go take a look at that. So simply reads the blob and writes it to the stream. And of course, at this point, you get to a standard Azure call, right? It is available, download to stream. So this is where we get the blob, dump it into the file, and go back to the worker role. There was no format file because the file was already formatted. It builds the parameters to BCP, and then it simply executes BCP, the command, and then it does some cleanup. And this is probably the speediest way because BCP is pretty fast as it is. And if the data is near, then you get the best experience. So recommendation is to take advantage of the Azure platform as much as possible. You can dump all of the logs. You can use the Azure queues for scheduling jobs. You drop something in the queue. You can use the Azure tables as a scheduling mechanism. You drop some and your status from the jobs, and the thing runs locally. So there are no current jobs, and here's the job status. And 821 was the last one. Again, UTC. So that's the job that completed. And I can go to that server and take a look at that table. Oh, sorry. Let me do this again. So this is a thing that you should know about. When you connect to SQL Azure and you don't tell it what you want to connect to, it defaults to master. So, which is a little well, it's standard practice, but unfortunately you can't say use and switch back. So I'll do a new query window. Hopefully this will work. There it is. So the rows are there. Let's see. Summary is treat SQL Azure like SQL Server, but do pay attention to the standard practices and best practices. And over the next few months, we will publish lots of papers on what are the best practices that are most important for SQL Azure, and we'll put some of these tooling out. Now, obviously, all the stuff that we do, we'll just push it to CodePlex, so it makes life a lot easier for you. Please remember to do the evaluation, and we have a few minutes for questions, if there are any questions. Yes?
Where is the SQL Azure BCP available?
The demo that I ran? The UI for the BCP, it was just finished a couple days ago for the demo. We'll push it to CodePlex so that you can have it. Yes?
You talked yesterday about backups, specifically clones, and something down the line that might be a point in time restore.
Yes.
I didn't hear anything about those today. Can you talk a little bit about those, how they're priced, if the data is always in sync between the backups and the primary, and if there can be a different, like north central or south central?
Yes, so the backup features we talked about, clone and continuous backup, will be available sometime in 2010. We don't have pricing information yet. The clone basically allows you to make a clone transactionally consistent clone of the database, which as soon as the clone operation is completed, becomes a distinct database of its own with no relationships. So it's not synchronized. It's simply a clone, which you can drop at any point. And you can use it for whatever reason. Continuous backup, on the other hand, when you configure it, you have to configure it with a retention period and a lag time, just like usual. You can think of it as closest to the mirroring stuff, right? And basically, you're in charge of deciding how long you want to keep the backups, and longer you keep them, most likely you might have to pay more, and so on. So most of that will be available next year. Yes? Yes?
Yeah, I mean, the only problem that I see is that we really don't have any control about the I/O characteristics or the CPU characteristics, and sometimes it might be hard to go that partitioning or sharding approach. And do you foresee that we will have any more control about that in the future, similar to like the multiple size VMs that Windows Azure has now? Or?
So with the different size databases, you do get different size resources. When we do the throttling, we do take into consideration what it is that you have paid for. So with SQL Azure, you really shouldn't think that you're just paying for space. You're paying for that database. And larger databases will require more resources. So that's a given. No, you just get to use more of the machine resources at any given time. Also, it's a shared system, so there are implications. Even in other shared systems where you do get a VM, you don't necessarily get full control of the I/O subsystem. The I/O subsystem in a shared machine is always shared. So if there are other VMs that are pounding the I/O subsystem, the network or the drives, you're impacted by that, even though you have a VM and you paid for a larger VM. If you go read all of the documentation, say, on most of the people who give you VMs on shared hardware, there's a small footnote that says, by the way, the I/O subsystem is shared, so your victim to your neighbors. And what we do is we try to govern the resources. We will not throttle you if there's no reason to throttle you, even if you exceed your limits. That is, let's say nobody's on the machine. It's 4 o'clock, I don't know, in the afternoon, and you're the only person happens to be running a query on that machine. We just let you have it. Now, if there are other users on the machine, then we will be more particular about throttling and keeping you under a certain limit. And as we come up with bigger and different sized databases, we will have a more particular and articulated set of limitations that you will have to program around. Yes?
You make heavy use of distributed transactions MSDTC in our application. Can you use them?
No, MSDTC is not supported. Distributed transactions are not supported on the multiple databases at this time.
Will they be?
I can't make any comments on that this time. Yes?
Will analysis services be a part of Azure at some point?
As in running it in the cloud? Yes. Today you can run SSAS from on-prem against SQL Azure, and that works. But having it hosted in the cloud, there's a whole set of activities that are happening. And I don't have any particular dates, but yes. The idea is that you extend the entire platform to the cloud someday. Yes?
Do we have access to features of enterprise version except for 2008, like the storage and compression capabilities?
So we don't distinguish on editions for SQL Azure. So all features are enabled in our version of code that we're using. However, some features are not enabled yet, and it's not because of the edition, it's just because we haven't enabled them yet. So compression and encryption are not enabled yet. We're still doing some work on testing. We have to, whenever we enable a feature, we have to make sure that it works consistency with failover and replication and all the other stuff, and that behaves properly in that environment. And in the shared system. So in case of encryption, you have to deal with the certificates and stuff. So we're going to enable that over time. Encryption was a big ask. We had a survey where we asked people if they wanted compression. No one wanted compression. We couldn't figure it out why. But I mean, you get more data in there, and we're paying for the CPU. But we still have it on the list, even though we got very little requests. So you should probably express your interest in that. I have some cards here for people. If you wanna send us stuff, please come take some of these cards, and there's an email address, and you can send an email.
Second question, do we have access, will you plan in the future to give us chances to configure somehow the disk system? A lot have been, if we are talking about SQL Server performance, then usually we are talking about RAID 5, RAID 10, RAID 1.
We will not give access to hardware. So the question was if we will ever give access to hardware configuration, and the answer is no.
Not necessarily low level.
Yeah, no. We manage the hardware, and that's part of the service. So that's not going to be a possibility. And just so you know, we don't use RAID functions. So I can talk to you more about it later. Yes?
You plan to establish some best practices for sharding.
Yes, there's a session on Thursday. Dave is going to present on sharding. And then if you saw the presentation yesterday with a lot of features that we're putting in specifically to help out with sharding, and that stuff will come in 2010. Yes?
So sometimes you've talked about the multiple databases that sit in the background as something like partition. Sometimes you've talked about them as something like clones. Do I have to be scared of doing a join that will, that will be crossing data centers or crossing machines and do horrible things?
No. When you create a server, and the geolocation of that server determines where all the databases on that server are, and they'll always be in the same cluster. That's a guarantee.
On the same cluster, but not necessarily the same machine.
That's correct.
So not all. So is there a way to guarantee that my joins will be local or to know? Or
No.
Okay.
We don't support distributed joins.
Okay.
This last question.
Is there a matrix on the site on either MSDN or at Microsoft that shows which SQL Server SKUs? Like, for example, could I use SQL Service Broker?
No.
Okay, so what other products am I going to run into problems with trying to use in the cloud, like SQL Server Reporting Services? I mean, you went over
So
SSIS.
the actual products should all work. So reporting services, SSAS, SSIS, and the tools work. SQL Agent and Broker don't work.
Right.
And the rest of them, do work. And if you have difficulty with anything that we've missed, you should be vocal about that on the forum, and we'll get back. All right, well, thanks. I'll be outside if there's more questions or if people want to chat. I'll hang outside. Come on by.